Hey there, I wrote a code formatter. Um, and yes, I'm writing a compiler again. I enjoy this sort of topic. I enjoy talking about and thinking about programming language semantics, so why not? What's one more side project? But with this one, I decided to jump right into the very interesting topic of code formatting, which, because it's something I have not tackled before, and there's surprisingly little written about it online. I did find at least one really good source, though, that had some interesting thoughts that I was able to apply. So let's play around with this a little bit, and then I can talk a little bit more about the implementation difficulties that makes this not as easy of a problem as you might expect it to be. So here we have a block. Inside we have this function being called with these parameters. And in here we have one of our parameters is another function. And then we have an empty scope out here, over here. And then we close that larger scope. And I can run this. And it just got formatted. Actually the entire file got erased and then re-outputted. That's a bug. I fully expect this to fall over a few times during this video because this is very young. I've only been working on this project for like 2 weeks ish, and most of that has been working on the parser. I don't really like working on parsers, but this is a interesting topic that I've not done before. So you can see it's decided that this function arguments should be split over multiple lines because it has a large number of them. If I were to remove all of this, it's now decided that that should be one thing. But if I type a lot more here, that's a bug. Yay! We found another bug. It can't handle that. But if we come over here and we do that, but then if I give it a really long argument name, it decided to split that, and I could come over here and add a few more, and it'll split those. If we chop this down, and then we try to get just to the edge that it will split, and we back off a bit so it unsplits. There we go. So that's our boundary for when it'll split and when it won't split. And if I add in another scope here, another level of indentation, it handles it. Again, if I remove these, ta-da! And I think I did just notice a bit of a bug. Yeah, that's a bit of a bug. Very interesting. I will have to look into that. I think I might know what's causing that. But let's talk a bit about comments, because comments are a pain in the ass. There we go. So we run that format. It's fine. Comments can appear anywhere, like literally anywhere in your program. Like between any two valid tokens, a comment can appear. It does not matter. It just can. So the formatter has to know that and be able to understand that. But you don't want to have to worry about that when you're writing your parser, because that makes your parser logic a lot more complicated. And trying to fit that information into your parse tree is a pain in the butt. But what is a lot simpler is having your parse tree store all of the tokens, so it becomes almost like a token tree, but not. This isn't technically a token tree. But it stores all of its tokens, and then the formatter, when it's going back through all of the tokens, can go look for, because each token has an ID, basically an index into a big. This is kind of inefficient. I have some ideas to make it less inefficient, but it can go and go, hey, look, I can see the last token I took care of was token 52, but this is token 54. I know I've skipped token 53. I should go check and look. Oh, look, it's a comment. And then the tokenizer, when it's handing off tokens to the parser, just doesn't hand it any blank lines or comment tokens, but instead stashes it away and then continues to read the next token to give that to the parser instead. So the parser doesn't have to worry about comments, doesn't have to worry about white space or anything, like the parser shouldn't have to worry about your white space or your comments or any of that stuff. But then that information is still kept around somewhere else, and the formatter can read rebuild that information. Getting things to split correctly is a bit of a pain in the butt. But not as big of a pain in the butt as I expected it to be, because like there's all this stuff like, oh, it's such a complicated problem because you're doing basically what, like, paragraph flowing and stuff. I didn't do that. Instead, it figures out, like, whenever it comes to a let's remove this format. Whenever it comes to a open of some kind, there are openers and closers. Right now, it's just braces, parentheses, and brackets. But eventually, I have a slightly smarter way for that information to be represented. But for now, that's how it is. So whenever it encounters one of these, it knows however many columns it's been going so far, and then it measures until it finds its closing, and then goes, yo, am I over the limit? And if so, every potential split point within itself gets split. But if you see here, this one doesn't get split, right? So we have a potential split here, we have a potential split here, here, and here, and those all got split on. But here and here did not, because while it included this in the measurement of this width, it knows that when it saw this, it then recursed, and then in here, it knows all of this width to measure its own width, but it does not inherit that, hey, I should be splitting on every potential split. So that makes it extremely simple, right? Splitting becomes extremely simple. And I can come in here and I can make this longer, and now that gets split. And I told you there were gonna be bugs. I told you there were gonna be bugs. Oh, that's funny. That's probably related to the same bug we were looking at earlier, where it didn't indent these. But and of course, line comments, like, you have to be able to differentiate between comment and comment. It has to be able to differentiate between those. And I just ooh, parse error. We have a parse error. Hold on. Oh, I'm silly. Boop. Ta-da. Oh, and of course, because there we go. It has to be able to differentiate between these two. So for line comments, I end up having to store, like, whether or not it's following any sort of content or not. So this one knows that it's following content, but this one's not. And of course, we can come over here and we can go do that, and it should handle it. Aha! That's a bug. I know why it's doing that. That's an easy fix, though, I think. It's inserting spaces afterwards, which is silly, but I know why it's doing that, because, like, if there's one of these, it unconditionally pads itself with a single space on each side, which is fairly simple to fix. There's a lot going on in your average code formatter. This handles very, very limited amount of syntax, honestly. Like, I mean, like, I can come in here and I can go say, let variable equal 5 usize, let other usize equal 42, if variable, this is going to be semantically incorrect, but 4.2, no, let's go 9, and then here we go, function variable other plus 8, and it should not handle that. Expected. Oh, okay. Oh, I removed that. Okay. There we go. It handled that. So it can handle like a fairly large amount of syntax at this point. Like, if I were to come in here and I'd be like, if I were to do this is gonna fall down because the parser can't handle that yet. The parser doesn't understand how to handle that yet. that's fairly simple to solve. Technically, the parser does understand precedence. The formatter doesn't care. Formatter doesn't care, but that precedence information is stored for the semantic pass later on. So this is all, it understands all this. So I could come over here and I can go, and it handles that. Run it, boom. VS Code's being dumb. That's weird. That's a bug in VS Code. Also, handling blank lines. So typically you want your code formatter to be able to handle when you have a shit ton of these, and you typically want it to be able to like get rid of those. A lot of code formatters, Rust format, which is what I use on a daily basis because this is written in Rust. I write a bunch of other stuff in Rust. It restricts you to single lines between stuff, which is annoying because like if I have multiple functions, right? I want multiple lines between the functions. I want 2 lines between the functions, and then inside a function body, I want 1 line between unrelated blocks. But Rust format doesn't let that. If we have 2 lines here, and we go cargo format, it'll get rid of that. But I want it to be, well, I mean, technically you can raise that amount, but it's not been stabilized, so you have to use a nightly compiler to be allowed to use it. So I wanted to not do that. So if you look, if I have a shit ton of blank lines here, it will limit to 2 blank lines, and if I have one blank line, it'll allow the 1 blank line. If I have no blank lines, it'll be fine with that. So, and I'm hitting F5. Oh my goodness gracious. There we go. VS Code's a bit of a pain in the butt sometimes. I've been trying to use the integrated terminal because one of the joys of this is not sarcasm. One of the joys of writing your own editor is becoming more aware of the feature set in your current editor that you aren't using to its fullest. So in writing superb text, I have been improving my usage of VS Code, which is good, but there's also like a bunch of issues with VS Code's implementation of a bunch of stuff. But anyway, so let's talk a bit now I've shown off a bunch of the formatting stuff. Like I can come in here and I can go, like it does not care. Like if I can do this, and like the parser's fine with that, but the formatter as the space is like stuff works, right? For the most part, stuff works, which is really cool. Something fun. The way the parser currently works, that's a token, and that's a token. So like I can do that. The formatter fixes it, but the parser's fine with it. Which means you can do this, which is technically still 5.9, and the parser is still happy with that. The parser knows that that's 5.9, which is funny. I'm gonna fix that, but right now I'm fine with it. It's funny though. I mean, like that's not really high priority, but it is funny. So let's talk a little bit about implementation. As I said, there's very little written about this sort of topic online. There's this great article though by Bob Nystrom. I think that's how you pronounce his last name. I didn't realize that's who it was when I first originally read the article, but then after rereading it again, I realized, oh shit, that's who the author is. This person, as a matter of fact, wrote the Crafting Interpreters book, which is pretty darn cool. Quite a bit of pedigree there. But when the article was written around like 2015, 2016, he was the head person working on the Dart formatter, the code formatter for the Dart programming language that Google's using for Flutter and shit now. I think at the time they were still pushing it for inclusion in web. I don't know if they had that. I don't know if that ship had sailed by that point or not yet. But anyway, he wrote this really good article. I'll probably link it below. If not, you can easily find it. I think it's titled like the hardest program I ever wrote, something like that. And he talked about splitting up the program not into quite tokens, but like the smallest units of program that cannot be split, which I found intriguing. but he was going a lot more fancy layout wise, to the point that like the Dart formatter at the time, at least, I don't know if this has changed. He explained had a failsafe that if it attempted to check too many different formatting options for a specific piece of code, it would choose the best one it had found so far and then continue, which is not what I'm doing, but it's quite interesting to think about. But that did inspire, partially, how I ended up implementing this. So, the core of the implementation is this enum right here, chunks, where a chunk is something I've found extremely useful in all sorts of programming. Excuse me. Is to take, when you have a complex set of inputs, it can be extremely useful to desugar those into a smaller set of more primitive operations. So you have some complex, in superb text, you can do a lot of really complex manipulations of the text because it is a multi-cursor, multi-selection text editor, right? So you can have, it's like this, right? So I can start typing weird stuff here, right? Like, this is not superb text, but VS Code has a similar feature, as does Sublime Text. I think a bunch of JetBrains editors have multi-cursors at this point as well. There's multi-cursors in most editors at this point. But for the undo and redo history system, being able to undo one of those edits or reapply that edit is a lot more complicated than I would want to implement. So instead, the core of the document accepts only insert new line at this index with this contents, remove the line at this index, or overwrite the entire line at this index with these new set of contents. And then for the insert and remove, there are also a variation of each that's bulk, so you give it a range of lines for performance reasons. So those 5 different core, all your edits you make to the document, no matter what, are desugared into some sequence of those 5 core edit operations, right? And then the history only has to understand those 5 core edit operations instead of all the different combinations of things you could be doing. I've done a similar thing here, where all of the tokens, all of the parsing rules and such become these. There's 1, 2, 3, 4, 5, 6, 7. There's 7. And then the formatter knows how to format these. We have a literal, which is just a bit of constant text, right? It's just a textual constant somewhere in the formatter. I don't think that we use these I don't think this is used very many places. There's like 1 or 2. Yeah, it's used for literally only for the open and close braces. When something needs open and close braces, but I should actually investigate if that's even necessary. And then we take a token, and then that's where all of the looking up ID and figuring out if you skipped anything like a comment or something, a space, and whether or not that space is potentially a split location, just a plain old split location, potential split location, somewhere that we're forced, this has to be a new line here, and then our 2 forms of contents with their comments with their text, and whether or not they are directly following some previous non-white space characters on that line. And that's it. And then all of the logic to be able to handle that, all of the trees, if we look through this file is like, yeah, a little over 700 lines. And each different parsed node knows how to take itself and then convert itself into a sequence of these chunks. And it basically buffered, like buffered IO, where you like write until you get to a new line, and then that actually gets put out to your file stream, which is a lot more efficient than doing a syscall every single time, right? Similar sort of concept here, except it's a lot more efficient to do it line by line instead of building up this giant list of all your chunks and then doing it all at once. So we have this parsed. Let's look for a something fairly simple. Yeah, we'll do this. Parsed call. This is a function call, right? This is our formatting object, and we push to it our chunks, and then the push just goes through and takes the chunk and first figures out if there are any comments or blank lines in the middle. Actually, we silently ignore blank lines here, but if there are any comments, we inject them and then continue on. And then we push that to our current list of chunks, and if we are forcing, if that is a concrete, like we have to split here, this has to be new line, we flush, which does actually all the formatting. And that means that this vector doesn't grow very much, because it only ever holds like up to like 20 something items, maybe. So that's pretty cool. And then down here we just have all this logic. And there's a bunch of other stuff, but that's the basics, and it's really it's fairly simple conceptually. And then we have a bunch of logic down here for like, here's actually where we take all of those different chunks and we write them out. And that's about all the logic there is. It's pretty cool. I did take a look at the, I poked at the Go formatter and the Zig formatter, but the Go formatter hooked into enough of other compiler stuff that without me like getting a full development build of the format of the Go compiler working locally, that I could like jump around the source and such, which is a bigger pain than it honestly should be. Go is a pain in the butt sometimes. I wouldn't have been able to figure that out. And then the Zig formatter is significantly more complex and nuanced than the Go formatter is, or than what I want it to be. So yeah, like I said, I've only been working on this for like 2 weeks. I imported the and it's a freaking tiny. Nope. It's tiny code base, like just over 2,000 lines. Tiny. I imported the parser, majority of the parser from an earlier project I was working on. And then like added stuff in so I could go and get nice, like this is all, I wrote all this. It's really not that difficult to like handle tabulators and stuff, like people. Anyway, that's a little bit of a jab at a friend. So now I guess I can talk a little bit about my plans for this as a compiler. At this point, I'm done talking about the formatter. Just a little bit of information about the compiler that I plan on writing. I'm looking forward to working on semantics finally. I don't like living in parser land too long. I find that the programming language community tends to have this fixation on parsing, this undue fixation on the topic of parsing, when it's like the semantics are the interesting part, because that's actually how you use the lengths. Anyway, that's a pet peeve of mine, but I want to play around with what sort of things are possible in the safe system programming language space, because there's frighteningly few solutions in that space right now, right? Like you've got, I would say for the most part right now, currently usable in the space of or a systems level programming language, and it's safe, would be Rust, Nim, and I think you could make the argument for D. There are a few other languages that are have some interesting ideas, like they're not system level programming languages though. Well, Lobster came up with this really interesting idea for memory management that's I'm not overly fond of, but it's better than what a lot of other languages have. And then Veil is implementing that at a fairly systems level perspective level, but like Rust and to an extent Nim, but Nim is its own special thing. It's technically usable as for deterministic real-time systems. Technically, but for someone who wants to write code that runs very fast, but write expressive code that I know is safe, and if it compiles, I know it's safe. It might not be logically correct, but I know it's not going to have some sort of redonkulous memory related bug or security issue down the road that I have no clue how to debug, because anywhere in my 10,000 lines of code, something's gone wrong, right? I mean, 10,000 lines is pretty short at this point. It's pretty darn small, but you get what I'm saying. So for me, who wants to write code in a language that like I can trust to have my back, but still not be hindered performance-wise, and be able to write code that takes advantage of hardware. It's frustrating that there are so few options, but at the same time, it's such a difficult proposition to try to make system-level, high-performance programming language that has all the safety you just get by including a GC and being done with it. I'm not sure how I want to solve anything, but I want to play around with it. I want to give myself the opportunity to experiment, and that's what this compiler is about. If I fail to come up with anything that's reasonably useful, I doubt I'll come up with it. As an individual, personally come up with anything anytime soon that's better than what's already available. I doubt that I'll be able to do anything like that. But if I can't come up with anything that's at least somewhat useful, I'll settle for this being an unsafe imperative language. But then say don't use it, but just get to the point that I can self-host it, because I just want to self-host something, because that's so freaking cool. Concept of a language being self-hosted is just such a cool it's just so cool. Like, you got your Rust, you got your Go, you got your Nim, soon to be Zig. Technically, Clang and GCC and such are technically self-hosted, but that's less interesting. I know a lot of Lisps can be self-hosted, but sitting down, creating a language, and then moving your entire language's ecosystem and supporting software, all your toolchain into the language is so cool. It's just so cool. So I want to be able to do that. So that's one of my other goals for this project. I don't expect this to be useful anytime soon. I do plan on making the repo public at some point in the next few months, as soon as I have any form of semantics and code gen in, which I don't expect to take very long to get very basic stuff in, because I've done it before. If I showed off a video of this compiler that I wrote a while ago, running on Serenity OS a few weeks ago. It's like 4,500 lines. It doesn't take that much to get basic stuff working. So, yeah, I look forward to playing around with this some more. This formatter needs more work, but for something I've never tackled before, for like a week and a half of work on this part, yeah, pretty cool. I'm pretty happy with it. So, that's all. Thank you very much for watching, and ta-ra!